All right, today what we're going to do is look at the last part of section 1.9. So this is in your notes packet, but you talked about on Friday part of 1.9, and you looked at percentiles, and that was a way to kind of gauge how you would do or what a score would look like in relation to others. So today what we're going to do is we're going to look at a way to maybe compare two separate tests or two separate sets of data and still have a comparison. So if I were to ask you this question, if I asked you, what's more impressive? If you were to score a 25 on a test when the class average was a 22, or scoring a 64 on a test when the average score was a 58. Which one would you deem to be more impressive? Well, as you thought about this, you may have wanted some more information. So when you're trying to answer this, what do you think some information might be that would be nice to know before you could actually answer it? So I want you to kind of pause the video and think about that for a second. All right, so some of the questions that usually I get on this is, all right, well, how many people took the test? That might be something that would affect your answer. A lot of people usually say, well, how many points was the test out of? For instance, if I said the first test was out of 100, well, maybe getting a 25 on it wasn't all that impressive, even though it was higher than the class average. Versus if the second test were out of 64, then you'd feel pretty good about that one. So those might have been some of the questions that you came up with as you're trying to decide which one's more impressive. Well, statistically, we want to have a way that we can actually make that decision. And so what we're going to start looking at is how we can standardize things with what's referred to as a z-score. So first of all, when we standardize something, you've heard the word standardized test before. Whenever you've done ISTEP or even ACT, SAT, those are all standardized tests. Well, what standardizing does is standardizing gives us a way to compare. Yeah, if I can get this, get this to work here. It gives us a way to compare with respect to the rest of the group. So in other words, I'm not just looking at my score, I'm looking at, well, how would I compare to other people who took that same test or in that same group? Like I said, we're going to use what's referred to as a z-score to help us. So here's what a z-score is. A z-score is the exact number of standard deviations a data value is above or below the mean. Well, that's kind of a fancy definition there. But what I would like you to understand is the fact that, first of all, it's just a way to measure things, the z-score is. And the measurement we're using is the standard deviation. Another thing to keep in mind is z-scores can be positive and can be negative based on whether they're above or below whatever our mean is. So here's an example. If I knew this information, if I knew the mean height of a sophomore boy is 68 inches, and I knew the standard deviation for that data was 2 inches, then I would say someone who is 70 inches tall has a z-score of +1 or +1 because they're 1 standard deviation above the average. They were 2 inches above the average, but every 2 inches would be considered 1 standard deviation. Versus a 64-inch boy has a z-score of -2 because they were 2 standard deviations below the average because they were 4 total inches, which was 2 sets of 2 inches. So again, z-scores can be positive, they can be negative. based on whether they're above or below the mean. Well, more importantly, right now, we're going to have a way of figuring out how to find the z-score, because unfortunately, not every value we look at is going to be exactly 1 or 2 or 3 standard deviations away, like those two examples. So we're going to use a formula to help us out. So this formula here is one we're going to use quite a bit. If you look at the formula, we're looking at the z-score. The parts of the formula, first of all, the x value, that's our data value. So that's whatever we're working with. X bar, we already know, is the mean. And then S is going to represent the standard deviation. So in order to find the z-score, I have to know those three things. I have to know what data value am I looking at, what's the mean of the data, and finally, what's the standard deviation of the data. So let's go back to the two examples. The first example, remember, we got a 25 when the average was a 22. Well, if I wanted to find the z-score of that data, I'm going to use my formula to help me. Well, my data value was 25 because that's what I got on the test. I'm going to take away from that the mean, which we said was 22. And I'm going to divide that by the standard deviation. So we're told now that the standard deviation is 1.7. So I'm going to type in 25 minus 22, or 3, divided by 1.7. And we're going to round all of our z-scores to 2 decimal places. So this one would be 1.76. Or in other words, we were 1.76 standard deviations above the mean. Well, let's compare that to the second test. Well, we're told for the second test, the standard deviation was a 3.3. I don't remember what was our score. So we got a 64 when the average was a 58. So our z-score for this one is 64 minus 58. And I'm going to divide that answer by 3.3. So 6 divided by 3.3 is 1.82. Or in other words, we were 1.82 standard deviations above the mean. All right, well, what's that tell us? Well, we've now taken those two separate tests and we put them on equal footing because they're both talking about z-scores now. So now I can make the determination of, well, which one was more impressive? Well, in this case, the more impressive one was the second test, and that's because it had a higher z-score. Or in other words, we were more standard deviations above the mean than what the first test was. So if I can find the z-score, that gives us an opportunity to compare two different kinds of tests. Maybe I want to compare the SAT and the ACT and how well I performed on that. Getting a z-score would help us do that. So again, what's a z-score do? Well, a z-score is going to be used to compare relative performance. And we've used the word relative before. We said how it relates to other people or other data in our set that we look at. So z-scores are a way to do that. They're going to be a relative performance. So let's try another example. Here's the example in this one. Mensa. You may have heard of Mensa before, but if not, that's the largest high IQ society. And it's basically a club, but this society or club accepts two ways of indicating intelligence. They accept the SAT scores or the traditional IQ tests. Well, assume that the mean for an SAT score is 1500 and the standard deviation is 300, and Jackie scored a combined 2070. Versus Maria, she decided to take the traditional IQ test. She scored a 129 And on that test, the mean is 100, standard deviation is 15. So what we want to do is try to determine from those test scores who would be considered more intelligent, or in other words, who actually performed better on their test. Well, this again is where z-scores come in. So our z-score for the first situation, it said that she scored a 2070. And I'm going to take away from that the mean, which they said was 1500. That then is going to be divided by 300. Now, be careful when you're entering this in. Make sure that you actually subtract first. So do the 2070 minus the 1500. And then I would go ahead and hit equals or enter, because that gives me 570. Then do your division. And so on this one, I get 1.9. Again, we always want to go to 2 decimal places, and that will be important when we get into the next chapter. All right, let's figure out Maria. Well, Maria scored a 129 on her test. The mean was 100. Standard deviation was 15. So 129 minus 100 is going to be 29 divided by 15 gives me 1.93. So based on the results of their tests, we would consider Maria to have scored better. And again, because she has a higher z-score. So again, z-scores, it's a way of looking at relative performance. We're going to, in the next chapter, see how percentiles and z-scores can tie together. And we'll do a lot with that as we start looking at what's called a bell curve. But for right now, I would expect you to know how to use the z-score, use the formula, I should say, for the z-score, and be able to make a comparison if I were to compare 2 different z-scores.